All right.
Hi everyone.
Hi.
Very good afternoon to all my friends and Dr. Shafiza. So today, our group are going to present our computer architects assignment. So firstly, I would like to introduce myself first. I am Sun Ji Xiang, 3 bank S3. My metric number is B 0218100044.
Okay. Next, my name is Najat Nabiha binti Azlan and my metric number B0217 21810127. Next view.
So, my name is Waria Nok Perempuan Riang. My metric number is B021810033. Next.
Hi, my name is Fatin Amira binti Abdul Latif. Metric number B0218101113. Okay. Soon?
Okay. So now we are going to present and demonstrate our first part A, which I would like to request Fatin to share screen.
All right, done.
Okay, thank you. So this is our lab sheet. So I need to request control first.
All right, done.
Okay. Wait. So okay. Firstly, what we wanna do is we need to for the Raspberry Pi simulator installation setup. So we need to download for two of the things, and we need to download the visualization software visuals from this website. Okay, from this website, and also the Raspbian OS image from this website. So means that we need to download two files. Okay. So after that, wait. Okay, after that, after the installation, wait. Okay, it will show like this. So, firstly, after we need to create a new folder, which in here. Okay, then we need to put a name. For example, like pixel. We already have the pixel, so we put like pixel 1. Then we just put we just choose the folder we want to store. Then after that, likeness, and follow the assignment lab sheet. We choose for the Debian 32-bit. So the Debian, the Linux is an operating system based on the Linux kernel. It is like an open source software. Okay. So after that, we click for next. The memory site which we choose for the 1024 MB, which is equal like 1 GB. Okay. These are the memory size setting. So for the hard disk, we choose for the create a visual hard disk drive. This is like a default setting for that. So after that, we create for this, and we choose for the VDI, Visual Box Disk Image, for the default setting. Then after that, next, for the storage on physical hard disk, we choose for the dynamical allocated. Okay, next. This file location as type, we also put 8 GB, and this is place that you store your file. Okay. Okay. Now these are what we created in the VM VirtualBox. So it shows the general system displays and storage, audio network, and USB and ATX. Okay. After that, we need to set up by clicking right click and click for the settings. So we can see the name of the pixel 1 and the likeness and div is what we choose just now. Okay. For system floppy optical, this display. Okay, we don't need to set anything. Okay, for the storage is very important part, which we need to add the IDE controller. This right?
Yeah.
Okay, IDE controller. Oh, okay.
Yes.
Okay, you all remember that just now the second file that we download is this, the Pixel ISO. So now we need to choose for this, which we need to put in the Raspbian desktop ISO. Okay, this is the one. So the controller SATA you show the Pixel 1 VDI. Okay. After that, just press OK. Then start. It may take a little time. Okay. Okay, just put start. Okay. You show out the VisualBox 6.1 Debian. Okay. Need to be patient. Okay. So it show out the Raspbian desktop here. Maybe you could put it bigger. Okay. Okay, now the first one we need to find it. Where is it? I can't see clearly. Oh, a bit.
You want to open the LTX terminal or?
I want to the preference. Wait,
preference. Back.
Wait, okay. Okay. Okay, at here. So firstly, we need to go in here, the mouse and keyboard setting. Okay. So we no need to set anything. Okay. Okay. Wait. A bit like. Okay. Okay, then after that, we need to set up our GPIO emulator by pressing the terminal icon. So this is the terminal icon. Okay. Then after that, we need to type the coding like the WGET HTTP / iot.ies/iot/mes/iot/smes.zip. Duplicate. Okay. Okay. So the HTTP request is sent. So now we're gonna unzip it. So we just press unzip. IoT. for SME.
Unzip PP.
Oh, sorry. IoT for SME.
Yes.
.zip.
Okay.
Okay, so so it show out the GPIO, the intro Python,
Okay. Mm.
GPIO drain emulator, the pin tester, and type checker. So means that the environment is ready for coding. Okay, so now I would like to pass the section B.
Section C.
Section
C.
C. Yeah, section C.
All right.
So I will start
So,
control first.
okay. Okay. So we're gonna go to section C. We skip section B because section B is hardware.
Yes.
So section C is simulation. And all right. Section C. So where's section C? Okay, so section C, we need to watching Raspberry Pi virtual memory. Okay, first, okay, we just need to start. Okay, wait. Okay, all right. So, okay, from the PDF given, we need to insert the VM start. Okay, okay, first of all, I am sorry because my laptop is here, so I might look at here either than the screen in my camera. So first we need to key in the coding of VMSTAT, VM start, and then it will appear this reading. Okay, this is the first reading. RB, SWPD, free, BUFF, cache, SISO, and else. Okay, so VM start is known as a virtual memory that is used to execute a simple memory monitor. The first step to execute this program is by open the Raspbian terminal window, LXT terminal, which is the black box. So this one is the LXT terminal. The black box is the LXT terminal. Okay. So VM start function is used to summarize the current state of Raspberry Pi and Raspberry Pi virtual memory system and update at a set time interval and a set number of times. So this is the first step we need to do for this section C task. First is open LXT terminal and type VM start. That I already show you. Okay, I already key in the VM start, and the result is display data of virtual memory system at the moment as in the picture below. So this is the picture I already snapped before. I done that before. So this is the outcomes, the reading. Okay.
Okay.
All right, so the next step, we can repeat this command after elapsed times interval and limit the number of repeat using VM start interval count, which is interval we can change the number, we can put any number of second at the interval and count. Okay, so what is the function of this coding? VM start is stand for virtual memory statistic, as I said before. So interval is a delay in second to read summarize the next state of Raspberry Pi virtual memory system and updates. And count is the number of memory being read. Okay, so in this picture below shows the 5-second delay to read 5 number of memory. Okay, so I'm gonna show you one example. Okay, this is the first we begin with the VM start. So now we try to put any value or any number at the interval and count. Okay, VM start 5 5 is means the time delay, and then space I press 5 is to read the 5 data. Okay, so as you can see in the screen, okay, we call our BSWPD and everything. This is a we call is a column, and this is our data. Okay, okay, done. Okay, so if you can see here, this is first row, first data, second data, third data, fourth data, and fifth data. Why we only have 5 data? Because we key in the 5 count. If we key in a 6 count, then a 6 data will be observed. Okay.
Okay.
So this is what I already done. Okay, I put 5 delay times and 5 data, and it will observe 5 data and give the measurement and the reading for 5 data. All right. So next, okay, we try to key in the VM start 510, which is we remain the time delay is still 5, but we want 10 data. We want 10 data, so that's why we put 10. Okay. However, on this section, on this tab, we need to open any others window to see the difference between the before measurement, the before reading and the after reading. What will happen if we open the window or anything like Chrome? So, okay. At here, I try to open Google. Okay, web browser. Okay, wait. All right. This is an example for this tab. Okay. Then I key in VM start 5, 10 because we want 10 data. Okay. Then here we can, enter, you can Google anything you want. The value are different. You can see here in this column, in the R column, there is nothing. The number is 0 only. But in starting from this part, you can see that the R is consists of number of 2. That means it has 2 program to run. I will explain later. Okay. So to make it short, this is the difference. Okay. This is the first one, no value at all at the R. And after we open any windows, then we can notice that there is number 2 in the fifth data. In the fifth data, there is a R is 2. The number of 2 is the R value starting to have value at fifth data. So this is the explanation. First, we have to run any Chromium software, or you open anything Windows you want. If you can see from here, this is 25. This is the first row, the first data, and the second data is still the same. The first one at the 3253,272, and the second reading is 253,024. So we start to read from here lah, because we see the change. So okay, in second to 10 data, in second, which means from this state in the second to last one to the 10 data, in the second to 10 data, Chromium is being run. in fifth row, data shows the R waiting to run 2 instruction. Okay, meaning that at here there is 2 instruction waiting to run. Okay, what is R? Okay, R is the number of process currently waiting to run. That's why I said the number of 2 here is the instruction that waiting to run. Okay, so on that time, the free is 253024. Okay. After the Chromium fully run, the unallocated memory is reduced to 112328. Okay. So you look at the free column. So this is a free column, as you can see here. So the 253024 is starting from here. Okay. And then it will reduce from this value to this value 112328. Okay, clear? So
Okay, clear.
for the cage observation in the cage column, okay, is increased from 394392. Okay, this is 394392. Starting the second data, and it will increase to 434376. Okay, it's increased the reading. So from this, the Chromium data is being read and stored to the memory. Okay, that's the function. Okay, next, from the first read for BI, here is a BI. Okay, you can see that the first row already have a reading, which is 44. Why? Why at the BI column, the first data has reading? It is because because of VM start command. Because we have a VM start command, that's why at the first data it reads 44 reading at the first data. So for the Chromium, the BI, as you can see here, BI, starting the fifth data, starting from the fifth data, it shows 75, and the last data, it shows 33. At the sixth data, it shows 33. So for the BO, here is a BO column. Okay, so for the BO, it is 0. All the BO data is 0. Why? Because the instruction for Open Chromium is just read, not write. So the instruction is just to read only. So if the instruction has read and write, at the BO column, we'll have any value lah. Alright. And the last, the free buff and cage. Okay, here, the free buff and cage column, the free buff and cage column value is changing. As you can see, there's a lot of number here, and it's different number, not the same number. Okay, it's changing from second to 10 data because during that time still has other instruction is being read and write at the memory. Okay, for the BI and BO, why the value is almost 0 and the most of the value is 0 is because the Chromium in ideals, so that there is no read or write condition. Okay, so if you want to know better, you need to understand this meaning, this column meaning. R for waiting to run, B, number of process, SWPD for page have been written out to swipe space, free is the amount of unallocated memory, that one, R, SWPD, free buff cache is already explained here. I have explained at here in this explanation. Okay, so this is the BI and BO, the number of blocks. Okay, that read from block device per second. Okay, and as you can see, SI and SO value here, SI and SO is all 0 because it's already stated that the amount of memory in kilobytes swept in per second is usually 0. So I think for the section C, I think that's all for section C. So we can proceed for section E because section E is the next simulation, right?
Right. Okay.
Okay.
So I can control.
Yes.
Where?
Wait.
Okay.
Okay. I'm waiting for control. All right. Done.
Okay. But where you put the?
Visual box.
Alright.
Okay.
Okay.
I think I need to run the session E part. Then you
Alright.
explain. Okay?
Okay. Right.
So let me run the session E punya part. Sorry, I think Biha can stop
Yeah.
control.
Yes. Yes. Alright.
Okay.
Done.
Okay.
Start over. Okay.
So
I
this is
think
the section A step by step. And Najat Nabiha and Warikia will explain more lah about this section.
Alright.
I just want to show how to create the coding and run the coding.
Alright.
So this is the first result, and then after we press on GPIO 15, then okay, the result will explain by Najat. Please.
Okay. Thank
Okay,
you.
take control.
Alright. Done. Okay. I cannot control.
Because wait. You already asked to take control? Okay.
Yeah. Okay.
All right.
Okay. Okay. From explanation, short explanation from Fatin. So I will to explain more about section E. So after you open the terminal box, sorry, lag. Okay. So you click the Raspberry Pi logo. You can choose the programming and click the Python 3 IDLE. So you can get the blank window programming like
LTX terminal.
yes, I did this
LX
terminal like this. Sorry, ni after display
This
output.
one. No.
Right. Okay.
Next. Okay.
Okay, and you click the okay. Okay, and you click the file and click new file. Sorry, so small. New file, and you can get this blank window. So after this, you need to type the coding like okay, type this coding. So for this coding part, Warikia will explain more detail. So next, I want to show you. Sorry, let
I can help you, I think.
okay. I stop control. Wait,
It's okay, don't need.
on there.
Okay.
Alright.
You just ask where to stop.
Okay.
This one.
Yes, yes. After you type the coding and you need to click run at the terminal, run and click. After click run, you need to click run module F5 and the coding start running. So at the same time, you can have error. So you can choose the open the folder. The name folder is Python p1 underscore gpio underscore test.py. So this can automatically to display the coding at the window terminal. So after that you can see that at the output display. So you can see the button GPIO. So the button GPIO we done set at the coding. So when you press the button, you can get the output. So when you step by step you need to press the button. So about the more explanation output button 0 or 1 Warikia will explain more detail. So next we using one two we using 3 button, right? 3 button or 4?
3 button.
3
4
button.
button.
4 button. GPIO 15, GPIO 23, and GPIO 24 and GPIO 26. So this is our input GPIO, and when you click the button, you can get the output. So Warikia, you can explain more detail about coding and about the output. Warikia, you can.
Okay. Okay.
I'm sorry.
Let we understand the coding for this part. From the emulator, show the GPO of the Raspberry in terms of GUI simulation. This is for coding for show the emulator GPIO Raspberry Pi in terms GUI. So after that, this
Emulator
is B
or D?
B.
B, this one.
Yes.
Okay.
For the G. Okay. For the GPIO 4 until 21, we set the output pin to integer low. So GPIO 23. So for the GPIO 23, to set the input pin as the value is 1. The value is 1 light is on or high. For the GPIO 15 and GPIO 24, to set the input pin as the value is 0. 0 is low. Then GPIO 26 to set as input pin. Yes, 26 GPIO in. So for C, why GPIO 23 is 0, the button is pressed. The GPIO and GPIO 17 is high. Then D, why the GPIO 15 is 0, the button is pressed. The GPIO 18 and GPIO 21 is high. Then if the GPIO 15 is 1, the button is pressed. GPIO 4 and GPIO 17 is low. So next,
I think it's GPIO 26.
yes, 26, sorry.
Yeah.
Sorry, 26, GPIO 26. If GPIO 26 is 1, the button is pressed. Then GPIO 4 and 17 is low. Okay, for the last of the coding, we clean exit the program. Okay. After that, we see the input, see the output. After we press the GPIO 15 is 0, the output is function in the GPIO 18 and GPIO 21 is 1. So each one is on, but the GPIO 4 and 17 is 0. Next, after press the GPIO 23, the output of GPIO 18, GPIO 4, GPIO 17, and GPIO 21 is 1. That means the output is on. Okay, see the picture. That is the GPIO is on.
Okay, let's zoom.
So next, after we press the GPIO 24, the output pin GPIO 18, GPIO 21 is 0, but the GPIO 17 and GPIO 4 is 1. Okay, we can see the color of green is GPIO is 0 and orange is GPIO is set 1. Next, after that, if we press the GPIO 26, the GPIO 18, GPIO 4, GPIO 17, and GPIO 21 is function that is out 0. All is green GPIO. That is mean 0 out.
Alright.
Okay.
Alright.
You can demo at the terminal about output.
Sure. I need to
Click
sorry.
the button. Alright.
Try to run it.
This one?
Yes, open file.
No, there's one.
Yeah.
Run.
Okay. Try. Explain again.
So,
So this is the first one. And then after we
Right.
press
This one.
GPIO 15.
file 15.
15,
The
GPIO 8.
output.
Okay. Out 1 is that is orange. For the color of green, GPIO 4 is out, GPIO 17 is 0. So next, and GPIO, okay,
GPIO 23.
23, when press the 23, the GPIO 18, 4, and 17 is function. So all is GPIO out 1.
Sorry interrupt. You don't forget the last pin out
Last
20.
26 still nothing, unchanged.
Okay.
Change. Okay.
Okay. No.
GPIO 24.
If 24 press, GPIO 18 is out. So GPIO 4 and 17 is 1. Out is 1. Next.
Okay. And then GPIO 26.
Okay, 26. Press the 26, the GPIO is function, GPIO 18, 4 and 17 is out. That is green color.
All right. So
Okay.
next
Okay,
for
this is
frequently question
all the
Q&A,
that
we give to Sun to explain.
Yes.
okay. So
Okay, control lah.
I already request.
Okay. I'm waiting. All right, done.
Okay. So thank you for very careful explaining. So for the last part,
okay.
okay, for the last part is the FAQ, frequently asked questions. So we have prepared 7 of the FAQ with the answer. Okay, so the first one, many people don't know about what is Python. So Python is a interpreted, interactive, object-oriented programming language, and it incorporates modules, exceptions, dynamic typing, and a very high-level dynamic data types and classes. So the Python combines remarkable powers with very clear syntax. It has interface to many system call and libraries, as well as to various Windows system, and is assembled in C or C++. Okay, and finally, the Python is portable. Is also run on many Unix variants on the Mac or the Windows, and later. Okay, for the next questions, is Python a good language for beginners programmers? Okay, for the beginners programmers, we don't know what where is what the programming we need to start. So it recommends for using the Python's programming for a student like us. So because the Python is like a very basic language lah, and is very simple and consistent syntax and large and more important, Python is a beginning programming course and let students concentrate in important programming skill lah, beside of using C++ on others. Okay. So for a student who never programmed before, using a statistic type language seems unnatural. So it's present addition complexity that the student must master and slow the pace of the course. Okay. So it's quite long. So overall is Python is recommends for student to use. Okay.
Okay.
Okay. For the third questions, how do I install Pythons? Okay. So for install Pythons, it requires a 25 MB of this space. To make sure you have the space before installing. So you can just install the Python at this website and just download the Python 3.9 is the latest one. Then scroll up and find you need to know very clearly about your PC, whether it's 64-bit or 32-bit. So you need to choose one, and yes, just install it. Very simple. Go to the fourth questions. So should I use Python 2 or Python 3? So it's very simple also. surely we need to choose for the latest one, the upgraded and updated one. But to show out what is the difference, okay, the Python tools still entrenched in the software of many companies, and many of the older libraries for Python 2 are not forward and are not updated. A string are stored at ASCII by default, and while for the Python 3s, we will take over Pythons by 2028 and after, and more libraries and create, and text strings are Unicode. So overall, is Python 3 is more updated and more powerful and more good than Python 2. Okay. Okay, go for the fifth questions. Why are the colons required for the if, while, therefore statement? So the colon is required primarily to enhance the readability lah. Okay.
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 This show up this one. Okay. If the first one and the second one, we can say that the second one is more clearly lah, and it's make easier for the editor to have the syntax highlighting. Yes. Okay. So for the six questions, what are the basic concept of Python? So this means that the function of the semicolons, the indentations, and the comments, the variables. So okay, for the semicolons, are used to finish the line. Unlike most the most programming program lah. Okay, the new line is enough for the interpreter to detect a new comment. So we should we need to for like this. For the examples, we need to print the first comment. We need to have the bracket and the semicolons. If you have the first one but the behind you didn't have the semicolon, you cannot print out the words. Okay. So for the intentionals, okay, most language will use curly bracket to define the scope of the code block. But the Pythons will simply determine throughout the intentional lah. Okay. Okay, like this. Okay. While for the comments, the comments is the green one. Means when you need to clarify your programming, what is the function of this programming, you need to clarify, and you need to put these symbols. But it's just a comment that it will not affect your programming.
The program, yeah.
Yes. Okay. Okay, there are still more. The variables, types, and the booleans, integers.
It's true.
I think is a very basic one. I don't need to explain by one. Yes. Okay, for the last questions, what is the function of the operators? Because operator is very important also. Some of us we do not understand about it. So these arithmetic operators and the comparison operators. So we can have to perform our mathematical operations very easily. So the addition, subtraction, multiplication, divisions, exponentials. For comparison, we have the equals, non-equal, greater than, less than, greater than or equal to, or less than. Okay. So those are the operators. So these are the 7 Q the question that we
Q&A.
Yes.
Only us.
Q&A.
So anything want to add on?
I don't think.
No.
But from this assignment, I think I learned something new, that how to operate the Python using a Python simulation VirtualBox, and I think that's my first time using Python simulation. And for Python hardware, we never not so get used to it, but last lab, right? Last time, we already try once for that. Yeah.
Yes. So that's all from us for the presentations. Thank you.
All right. Thank you.
Thank
Thank you all.
you.
Thank you, Doctor.
Thank you.
Thank you.
Thank you, Doctor.
Thank you, Doctor.